Welcome. There is a planet suspended in the vast quiet of space, turning slowly in a rhythm so steady that it has marked the passage of time for billions of years. This planet is Earth, our home, a world defined by balance, motion, and intricate systems that operate continuously, whether noticed or not. From a distance, it appears as a soft blue sphere, streaked with white clouds and hints of green and brown beneath the atmosphere. It is the only known place where oceans stretch across the surface, where liquid water flows freely, and where the conditions allow for an extraordinary range of environments. Earth is the third planet from the Sun, orbiting at an average distance of about 150 million kilometers. This distance is often called an astronomical unit, and it places Earth in a region where temperatures allow water to exist in solid, liquid, and gaseous forms. The planet completes one full orbit around the Sun in approximately 365 days, creating the cycle we recognize as a year. At the same time, Earth rotates on its axis, completing one full rotation in about 24 hours, giving rise to the steady alternation of day and night. The axis on which Earth rotates is tilted at an angle of about 23.5 degrees. This tilt is responsible for the gradual change of seasons as the planet moves along its orbit. Different regions receive varying amounts of sunlight throughout the year, creating cycles of warmth and coolness that repeat with remarkable consistency. These patterns influence landscapes, oceans, and atmospheric movement, shaping the rhythms that define life on the surface. Earth has a diameter of roughly 12,700 kilometers, making it the largest of the rocky planets in the inner solar system. Its mass and gravity are strong enough to hold a thick atmosphere, a protective envelope of gases that surrounds the planet. This atmosphere is composed primarily of nitrogen and oxygen, along with smaller amounts of other gases. It serves many essential functions, including moderating temperature, filtering incoming solar radiation, and enabling the scattering of light that gives the sky its familiar blue color. Above the surface, the atmosphere is layered, each region defined by changes in temperature and composition. Closest to the ground is the troposphere, where clouds form and weather occurs. Above that lies the stratosphere, home to the ozone layer, which absorbs much of the sun's ultraviolet radiation. Higher still are the mesosphere, thermosphere, and exosphere, each extending farther into space, gradually thinning until they merge with the near vacuum beyond. The surface of Earth is divided into continents and oceans. About 71% of the planet is covered by water, primarily in vast oceans that connect to form a continuous global body. These oceans vary in depth, with some regions descending more than 10 kilometers beneath the surface. The remaining land is arranged into continents, each with its own distinct geography, from expansive plains and dense forests to towering mountain ranges and arid deserts. Beneath the surface, Earth is structured in layers. The outermost layer, known as the crust, is relatively thin and broken into large sections called tectonic plates. These plates move slowly over time, driven by processes deep within the planet. Below the crust lies the mantle, a thick layer of rock that behaves in a slow, flowing manner, over long timescales. At the center is the core, divided into a liquid outer core and a solid inner core, composed mainly of iron and nickel. The motion within the outer core generates Earth's magnetic field, an invisible force that extends into space and helps shield the planet from charged particles emitted by the sun. The magnetic field creates regions near the poles where energetic particles interact with the atmosphere, producing faint, shifting lights known as auroras. These displays appear as soft curtains of green, red, and purple, moving silently across the sky. They are a reminder of the dynamic interactions between Earth and its surrounding space environment. Water plays a central role in shaping the planet. It exists in oceans, rivers, lakes, glaciers, and beneath the ground. It moves continuously through a cycle of evaporation, condensation, and precipitation. Solar energy causes water to evaporate from the surface, rising into the atmosphere, where it cools and forms clouds. Eventually, it returns to the surface as rain or snow, replenishing bodies of water and sustaining ecosystems across the globe. The oceans themselves are in constant motion. Currents flow across vast distances, driven by wind, temperature differences, and the rotation of the Earth. These currents transport heat from one region to another, contributing to the overall balance of the planet's temperature. Along coastlines, waves form as wind transfers energy to the water, creating rhythmic patterns that repeat endlessly, shaping shorelines over time. On land, the surface is continually being shaped. Mountains rise gradually as tectonic forces push the crust upward. At the same time, wind and water wear these structures down through erosion, carrying particles away and depositing them elsewhere. Rivers carve valleys. Glaciers move slowly across the landscape, and sediments accumulate in layers that record the passage of time. Earth is accompanied by a single natural satellite, the Moon. It orbits the planet at an average distance of about 384,000 kilometers. The gravitational interaction between Earth and the Moon gives rise to tides, the regular rising and falling of ocean levels. As the Moon orbits, its position relative to the Earth and Sun changes, creating phases that range from new to full, repeating in a cycle that has been observed for countless generations. The presence of the Moon also contributes to the stability of Earth's axial tilt. This stability helps maintain relatively consistent seasonal patterns over long periods. Without it, the angle of the planet's tilt could vary more dramatically, leading to less predictable changes in climate and environmental conditions. From space, Earth's appearance changes constantly. Clouds shift and swirl, covering and uncovering the surface below. Storm systems form over oceans and move across continents, sometimes spanning thousands of kilometers. At night, clusters of lights reveal patterns of human activity, tracing coastlines and marking cities. Yet beyond these lights, vast regions remain dark, reflecting the scale and diversity of the planet. The Sun, the central star of the solar system, provides the energy that drives many of Earth's processes. Light and heat from the Sun reach the planet after traveling across space for about 8 minutes. This energy warms the surface, powers the movement of air and water, and supports the cycles that sustain ecosystems. Despite its complexity, Earth operates through systems that are interconnected. The atmosphere, oceans, land, and interior all interact, exchanging energy and materials in ways that maintain a dynamic balance. These interactions occur over timescales that range from moments to millions of years, creating patterns that are both steady and ever-changing. As the planet continues its quiet rotation, day transitions into night, and night returns to day. The cycle repeats without interruption, a steady rhythm that has continued far beyond human observation. In this motion, there is a sense of continuity, a reminder that Earth is not static, but constantly in motion, turning through space in a way that is both gentle and precise. And as we continue, we move deeper into the details of this world, exploring the layers, the forces, and the subtle patterns that make Earth a place of remarkable stability and quiet complexity. Beneath the quiet landscapes and shifting oceans of Earth lies a vast interior that remains hidden from direct view, yet constantly influences the surface above. Though we cannot travel to these depths, careful observation and measurement allow scientists to understand the structure of the planet with remarkable detail. By studying the way seismic waves move through the Earth during natural vibrations, it becomes possible to map the layers below, revealing a world that is both dynamic and structured. The outermost layer, known as the crust, forms the surface on which continents and oceans rest. It is the thinnest of Earth's layers, varying in thickness from about 5 kilometers beneath the oceans to up to 70 kilometers beneath large mountain ranges. Despite its relative thinness, the crust is incredibly important, as it supports the landscapes, ecosystems, and structures that define the visible world. The crust is not a single, continuous shell. Instead, it is divided into large sections called tectonic plates. These plates fit together like pieces of a vast puzzle, covering the entire surface of the planet. They are constantly in motion, though the movement is so slow that it is measured in centimeters per year. Over long periods of time, this motion reshapes the surface, creating mountains, opening oceans, and shifting continents across the globe. Beneath the crust lies the mantle, a thick layer that extends to a depth of about 2,900 kilometers. The mantle is composed of rock that behaves differently depending on depth and temperature. In some regions, it is solid and rigid, while in others it flows slowly, almost like a very thick liquid. This slow movement, driven by heat rising from deeper within the Earth, creates convection currents that play a key role in moving the tectonic plates above. These currents operate over immense spans of time. Heated material from deeper regions rises toward the surface, cools, and then sinks again, creating a continuous cycle. As this motion occurs, it exerts forces on the base of the tectonic plates, guiding their gradual movement. The interaction between plates can take several forms, each producing different features on the surface. In some places, plates move away from one another. These regions are known as divergent boundaries. As the plates separate, magma from the mantle rises to fill the gap, cooling and solidifying to form new crust. This process occurs along mid-ocean ridges, long underwater mountain chains that extend across the ocean floor. Over time, this continuous creation of new crust slowly expands the ocean basins. In other regions, plates move toward one another, forming convergent boundaries. When this happens, one plate may be forced beneath another in a process known as subduction. The descending plate moves into the mantle, where it gradually melts due to increasing temperature and pressure. This process can lead to the formation of volcanic arcs, where molten material rises back toward the surface and erupts as lava. Where two continental plates meet, neither easily sinks beneath the other due to their lower density. Instead, they push against each other, causing the crust to fold and rise. Over time, this process forms large mountain ranges, some of which extend for thousands of kilometers. These mountains continue to evolve, shaped by both the forces that create them and the erosion that gradually wears them down. At transform boundaries, plates slide past one another horizontally. This movement can create stress along faults, which is released in sudden shifts known as earthquakes. These events vary in intensity, from subtle vibrations to powerful movements that can alter the landscape. Though often brief, earthquakes provide important information about the structure of the Earth, as the waves they generate travel through the interior and are recorded by instruments around the world. Deeper still lies the outer core, a layer composed primarily of molten iron and nickel. This region extends from about 2,900 kilometers to roughly 5,100 kilometers beneath the surface. The movement of liquid metal within the outer core generates Earth's magnetic field through a process known as the geodynamo. As the molten material flows and rotates, it creates electrical currents, which in turn produce magnetic fields that extend far into space. At the very center of the planet is the inner core, a solid sphere composed mainly of iron and nickel. Despite the extremely high temperatures, which are comparable to the surface of the Sun, the immense pressure at this depth keeps the inner core in a solid state. It has a radius of about 1,200 kilometers and plays an important role in the overall structure and behavior of the planet. The heat within Earth's interior comes from several sources. Some of it is residual heat from the planet's formation, while a significant portion is generated by the gradual decay of radioactive elements within the mantle and crust. This heat drives the slow movement of material within the mantle and contributes to the dynamic processes that shape the surface. Volcanoes provide a direct connection between the interior and the surface. They form in regions where molten rock, known as magma, rises through the crust and emerges as lava. This can occur at plate boundaries or at hotspots, where plumes of hot material rise from deep within the mantle. As lava cools, it solidifies into new rock, gradually building layers over time. Some volcanoes form islands in the ocean, while others rise on land, becoming prominent features in the landscape. The materials that make up Earth are constantly being recycled through these processes. Rock from the surface can be drawn down into the mantle through subduction, where it is transformed by heat and pressure. At the same time, new material rises from below, creating fresh crust. This ongoing cycle ensures that the surface is continually renewed, even though the changes occur slowly. Minerals and elements within the Earth are distributed in different ways depending on depth and conditions. Heavier elements tend to sink toward the core, while lighter materials remain closer to the surface. This separation occurred early in the planet's history and contributed to the layered structure observed today. The study of Earth's interior is an ongoing process, supported by advances in technology and observation. Instruments placed around the world record vibrations, measure magnetic fields, and monitor subtle changes in the planet's shape. These measurements provide insights into processes that occur far below the surface, helping to build a clearer understanding of how the Earth functions as a whole. Though hidden from view, the interior of Earth is not still. It is a place of motion, heat, and transformation, where forces operate on scales both vast and subtle. These forces shape the continents, influence the oceans, and contribute to the steady evolution of the planet's surface. As we continue to explore, we move outward again, returning to the surface where these deep processes express themselves in landscapes, oceans, and the gentle patterns that define the visible world. Across the surface of Earth, the oceans form a vast and continuous body of water, stretching beyond the horizon in every direction. They cover more than 2/3 of the planet, shaping its appearance from space and influencing nearly every system that operates within it. Though divided into named regions, these waters are all connected, forming a single global ocean that moves in slow, steady patterns. The oceans vary greatly in depth. Along the edges of continents, the seafloor slopes gently downward in areas known as continental shelves. These regions are relatively shallow and receive sunlight that penetrates the water, allowing a wide range of activity to take place. Beyond the shelves, the seafloor descends more steeply into the deep ocean basins, where depths can reach several kilometers. In some places, narrow trenches extend even farther downward, forming the deepest parts of the ocean. Light behaves differently as it travels through water. Near the surface, sunlight illuminates the upper layers, creating a zone where visibility is greatest. As depth increases, light fades gradually, shifting toward darker shades of blue before disappearing entirely. Below a certain depth, the ocean exists in complete darkness, a quiet environment where conditions remain stable and undisturbed by surface changes. Temperature in the oceans is not uniform. The surface waters are warmed by sunlight, especially in regions closer to the equator. As depth increases, temperatures decrease, creating layers within the ocean that are separated by gradual transitions. These layers influence how water moves, as differences in temperature and density guide the formation of currents that travel across great distances. Ocean currents are among the most important features of the marine environment. Some are driven by wind patterns at the surface, forming large circular systems known as gyres. These currents move water horizontally, carrying heat and energy from one region to another. Warm currents flow away from equatorial regions, while cooler currents move toward them, contributing to a balanced distribution of temperature across the planet. Deeper currents are driven by differences in density, which are influenced by both temperature and salinity. Colder, saltier water is denser and tends to sink, while warmer, less salty water remains closer to the surface. This process creates a slow but powerful circulation system that moves water through the depths of the oceans, connecting distant regions over long periods of time. Waves form at the surface as wind transfers energy to the water. These waves travel across the ocean, rising and falling in rhythmic patterns. As they approach land, their behavior changes. The interaction with the seafloor causes waves to slow and increase in height, eventually breaking along the shore. This continuous motion shapes coastlines, redistributing sand and altering the contours of beaches over time. Tides are another regular movement of ocean water, caused primarily by the gravitational interaction between Earth and the Moon, along with the influence of the Sun. As these forces act on the planet, they create a gentle bulging of ocean water, leading to predictable rises and falls in sea level. These changes occur in cycles, often twice each day, and vary in magnitude depending on the alignment of Earth, the Moon, and the Sun. Water itself has properties that make it essential to the functioning of Earth systems. It has a high capacity to store heat, which allows the oceans to absorb and release energy slowly. This helps to moderate temperatures, preventing rapid changes and contributing to overall stability. Water also dissolves a wide range of substances, enabling it to transport minerals and nutrients across vast distances. The surface of the ocean is in constant exchange with the atmosphere above. Gases move between air and water, while heat is transferred through direct contact. Evaporation plays a key role in this interaction. When water absorbs enough energy, it changes from liquid to vapor, rising into the atmosphere. This process removes heat from the ocean and contributes to the formation of clouds. As water vapor rises, it cools and condenses into tiny droplets, forming clouds that drift with the movement of air. Eventually, these droplets combine and fall back to the surface as precipitation. Some of this water returns directly to the oceans, while some falls on land, beginning a journey through rivers, lakes, and underground pathways, before eventually making its way back to the sea. Rivers act as pathways that connect land to ocean. They carry water from higher elevations to lower ones, shaped by gravity and the contours of the terrain. Along the way, they transport sediments, gradually carving valleys and shaping the landscape. When rivers reach the ocean, they often form deltas, where sediments are deposited in branching patterns that extend outward into the water. Beneath the surface, the ocean floor is far from uniform. It includes vast plains, underwater mountains, and long ridges that mark the boundaries of tectonic plates. In some regions, hydrothermal vents release heated, mineral-rich water from beneath the crust. These vents create localized environments where chemical energy supports unique systems that exist independently of sunlight. The color of the ocean, as seen from above, varies depending on depth, content, and angle of light. In deep, clear water, shorter wavelengths of light are scattered, giving the ocean its characteristic blue appearance. In shallower areas, or where sediments and particles are present, the color may shift toward green or even brown, reflecting the diversity of conditions across different regions. Ice also plays a role in the global water system. In colder regions, water freezes to form sea ice, glaciers, and ice sheets. These frozen forms store large amounts of water and influence ocean circulation as they form and melt. The presence of ice alters the reflectivity of the surface, affecting how much sunlight is absorbed or reflected back into space. The movement of water across the planet is continuous and interconnected. From the surface of the oceans to the depths below, from rising vapor to falling rain, water is always in motion. These processes occur quietly, often unnoticed, yet they shape the environment in fundamental ways. Over long periods of time, the oceans have maintained their presence, shifting in form and distribution, but remaining a defining feature of Earth. Their steady rhythms, from the rise and fall of tides to the slow drift of currents, create patterns that are both predictable and endlessly varied. As we continue, we move from the water that covers most of the planet to the land that rises above it, exploring the shapes, textures, and formations that define Earth's continents. Rising above the surface of the oceans, the continents form the visible structure of Earth's land. They are vast, varied, and constantly changing over long spans of time. From high mountain ranges to low plains, from dry deserts to fertile valleys, the land presents a wide range of forms shaped by both internal forces and surface processes, working together in quiet balance. The continents are composed primarily of thicker crust than the ocean floor, allowing them to stand at higher elevations. Though often described as stable, they are in slow motion, carried by the movement of tectonic plates. Over millions of years, continents shift position, sometimes moving apart, sometimes coming together, forming and reforming the arrangement of land across the planet. Mountains are among the most striking features of the continent. They rise gradually, where tectonic forces push sections of the crust upward. Some mountain ranges form where plates collide, folding layers of rock into ridges that extend for great distances. Others are created by volcanic activity, where material from below builds upward over time. Though they may appear permanent, mountains are continuously shaped by erosion, as wind, water, and ice wear them down. The highest peaks reach into thinner layers of the atmosphere, where temperatures are lower and conditions can be more severe. Snow often accumulates at these elevations, forming glaciers that move slowly downhill under their own weight. As glaciers advance, they carve valleys and transport rock, leaving behind distinctive patterns in the landscape. Beyond the mountains lie broad plains, areas of relatively flat land that can extend across entire regions. These plains are often formed by the deposition of sediments carried by rivers over long periods. Layer by layer, these materials build up, creating fertile soils that support a wide range of vegetation. The gentle contours of plains contrast with the steep slopes of mountainous regions, offering a different kind of stability and openness. Plateaus rise above surrounding areas, forming elevated regions with relatively flat surfaces. They are often created by uplift or by the accumulation of volcanic material. Over time, erosion can carve deep canyons into these surfaces, revealing layers of rock that record the history of the land. These layers vary in color and composition, reflecting changes that occurred over long periods. Deserts occupy regions where precipitation is limited and evaporation rates are high. In these areas, the landscape is shaped primarily by wind and occasional rainfall. Sand dunes form where loose particles are carried and deposited by the wind, creating shifting patterns that change over time. In other deserts, rocky surfaces dominate, with exposed stone shaped by gradual weathering. Coastlines mark the boundary between land and ocean. They vary greatly in form, from smooth sandy beaches to rugged cliffs that rise sharply from the water. Waves play a central role in shaping these edges, eroding some areas while depositing material in others. Over time, coastlines can change significantly, influenced by both the movement of water and the shifting of land. Rivers cut through the continents, forming networks that connect highlands to the sea. They begin as small streams, often in mountainous regions, and grow as they collect water from surrounding areas. As they flow, they erode the land, carrying sediments that are deposited elsewhere. This process creates valleys, floodplains, and deltas, each with its own distinct characteristics. Lakes form where water collects in natural basins. Some are created by tectonic activity, others by glacial movement or the blocking of rivers. These bodies of water vary in size and depth, from small, shallow ponds to vast lakes that stretch across large regions. They act as reservoirs, storing water and influencing local conditions. Soil covers much of the land surface, forming a thin but essential layer that supports plant life. It is created through the breakdown of rock combined with organic material. The composition of soil varies depending on climate, parent material, and biological activity. Over time, soils develop layers, each with distinct properties that reflect the processes that form them. Weathering is the process by which rocks are broken down into smaller pieces. This can occur through physical means, such as the expansion of water when it freezes, or through chemical reactions that alter the composition of minerals. Once broken down, these materials can be transported by wind, water, or ice, contributing to the reshaping of the landscape. Erosion works alongside weathering, moving material from one place to another. Rivers carry sediments downstream, wind lifts and deposits fine particles, and glaciers transport large amounts of rock across the land. These processes are continuous, gradually altering the shape of the continents over long periods. Volcanic regions add another dimension to the landscape. When magma reaches the surface, it cools and solidifies, forming new rock. Repeated eruptions can build large structures, creating mountains or plateaus. The materials released during these events can also spread across surrounding areas, influencing the composition of the land. Canyons form where rivers cut deeply into the ground, often over millions of years. These features reveal layers of rock that provide insight into the history of the region. The walls of a canyon may display bands of different colors, each representing a different period of formation. The arrangement of continents influences the movement of air and water across the planet. Large land masses affect wind patterns, while the presence of mountains can redirect airflow, creating variations in temperature and precipitation. These interactions contribute to the diversity of environments found across different regions. Islands are smaller landforms surrounded by water. Some are formed by volcanic activity, rising from the ocean floor, while others are fragments of larger land masses that have become separated. Despite their size, islands can display a wide range of landscapes, from steep cliffs to gentle beaches. Over long timescales, the positions of continents have changed significantly. They have joined together to form larger landmasses and then separated again, drifting across the surface of the planet. This ongoing movement continues today, though it is too slow to be observed directly within a single lifetime. The land, like the oceans, is part of a dynamic system. It is shaped by forces from within the earth and by processes that act on the surface. These forces work together to create the features we see, from the highest peaks to the lowest valleys. As the continents continue their slow motion, the landscapes upon them evolve, maintaining a balance between creation and erosion. The shapes we see today are part of a long sequence of change, a moment in an ongoing process that extends far beyond immediate observation. And as we move forward, we turn our attention upward to the atmosphere that surrounds the planet, exploring the layers of air that envelop the Earth and influence the conditions at the surface. Surrounding the solid surface and flowing oceans of Earth is a vast envelope of air known as the atmosphere. Though invisible, it is present everywhere, extending upward from the ground into space, gradually thinning with height. This layer of gases is essential to many of the processes that shape the planet, influencing temperature, distributing energy, and creating the patterns of motion we recognize as weather. The atmosphere is held in place by gravity, forming a protective boundary between Earth and the vacuum beyond. Its composition is primarily nitrogen and oxygen, along with smaller amounts of other gases. Though these components remain relatively consistent, their distribution and behavior change with altitude, forming layers that each have distinct characteristics. Closest to the surface is the troposphere, the lowest layer of the atmosphere. This is where nearly all weather occurs. Clouds form here, winds move across the landscape, and temperature varies from place to place and from moment to moment. The troposphere extends upward to a height that varies depending on location, generally reaching higher above warmer regions and lower above cooler ones. Within this layer, air is in constant motion. Warm air near the surface rises, while cooler air descends, creating circulation patterns that transport heat and moisture. These movements are driven by the uneven heating of the Earth's surface, as some regions receive more sunlight than others. The result is a continuous flow of air that connects distant parts of the planet. Above the troposphere lies the stratosphere, a more stable layer where temperature begins to increase with height. This warming is due to the presence of ozone, a form of oxygen that absorbs ultraviolet radiation from the sun. By absorbing this energy, the ozone layer helps protect the surface from radiation that would otherwise be more intense. Higher still is the mesosphere, where temperatures once again decrease with altitude. This is a region where incoming particles from space often burn up upon entering the atmosphere, creating brief streaks of light that can sometimes be seen from the ground. Above the mesosphere lies the thermosphere, where temperatures rise sharply and the air becomes extremely thin. In this region, particles can become energized, contributing to phenomena such as the auroras near the polar regions. The outermost layer is the exosphere, where the atmosphere gradually fades into space. Here, particles are so sparse that they can travel long distances without interacting with one another. Though it marks the edge of the atmosphere, there is no sharp boundary, only a gradual transition. Air pressure decreases with altitude, meaning that the air becomes less dense as one moves higher above the surface. At sea level, the weight of the air above creates a relatively high pressure. As altitude increases, there is less air overhead, and pressure decreases accordingly. This change influences both the behavior of the atmosphere and the conditions experienced at different elevations. Wind is the movement of air from areas of higher pressure to areas of lower pressure. This movement is influenced by the rotation of the Earth, which causes winds to follow curved paths rather than straight lines. Large-scale wind patterns develop as a result, forming belts of circulation that extend across the planet. Near the equator, warm air rises, creating a region of lower pressure. As this air moves away from the equator and cools, it descends at higher latitudes, forming areas of higher pressure. This cycle repeats in a series of cells that distribute heat and moisture around the globe. These patterns are steady in their general form, though they can shift and vary over time. Clouds form when water vapor in the air cools and condenses into tiny droplets. These droplets gather together, becoming visible as clouds that drift through the sky. The shape and type of a cloud depend on the conditions in which it forms. Some appear as thin, wispy strands high in the atmosphere, while others form thick layers or towering structures that extend vertically. Precipitation occurs when droplets within clouds grow large enough to fall to the surface. This can take the form of rain, snow, sleet, or hail, depending on temperature and atmospheric conditions. As precipitation falls, it returns water to the surface, continuing the cycle that connects the atmosphere to the oceans and land. Storm systems develop when there are strong differences in temperature and pressure. These systems can vary in size and intensity, from small localized events to large formations that span entire regions. Within a storm, air moves more rapidly, clouds become denser, and precipitation may increase. Lightning can occur as electrical charges build and discharge within clouds or between clouds and the ground. The atmosphere also plays a role in regulating temperature. During the day, sunlight warms the surface, and some of this heat is transferred to the air. At night, the surface cools, releasing heat back into the atmosphere. This exchange helps moderate temperature changes, creating a balance that prevents extremes from becoming too severe. Humidity refers to the amount of water vapor present in the air. It varies depending on temperature and location. Warmer air can hold more moisture, while cooler air holds less. Changes in humidity influence how the air feels and affect the formation of clouds and precipitation. The interaction between the atmosphere and the surface is continuous. Land and water absorb and release heat at different rates, creating variations that influence local conditions. Coastal regions often experience more moderate changes, while inland areas may see greater differences between day and night. Air currents extend across vast distances, linking regions that are far apart. Dust, moisture, and even small particles can be carried from one part of the world to another. These movements contribute to the interconnected nature of the atmosphere, where changes in one area can influence conditions elsewhere. At higher altitudes, fast-moving streams of air, known as jet streams, flow from west to east. These narrow bands of strong winds guide the movement of weather systems, influencing their direction and speed. Though invisible from the ground, they play an important role in shaping patterns of weather over large areas. The sky itself changes in appearance, depending on the position of the sun and the composition of the atmosphere. During the day, shorter wavelengths of light are scattered, giving the sky its blue color. At sunrise and sunset, light passes through more of the atmosphere, scattering different wavelengths and producing shades of red, orange, and pink. As evening approaches, the atmosphere gradually darkens, revealing the stars beyond. The transition from day to night occurs smoothly, following the steady rotation of the Earth. This cycle repeats with precision, creating a rhythm that has been observed throughout human history. The atmosphere is not a static layer, but a dynamic system, constantly in motion. Its patterns are shaped by energy from the sun, the rotation of the Earth, and the interactions between air, water, and land. Though often unseen, its influence is present in every moment, from the gentle movement of a breeze to the formation of clouds high above. As we continue, we move from the air that surrounds the planet to the subtle interactions between Earth and the space beyond, exploring the magnetic field, the influence of the sun, and the quiet connections that extend far beyond the atmosphere. Beyond the uppermost layers of the atmosphere, Earth transitions gradually into the wider environment of space. Though it may appear that the planet exists in isolation, it is constantly interacting with its surroundings in ways that are subtle yet continuous. These interactions are guided by invisible forces, streams of energy, and fields that extend far beyond the visible surface. One of the most important of these is Earth's magnetic field, generated deep within the planet's outer core, where molten iron moves in slow, complex patterns. This field surrounds the Earth in a region known as the magnetosphere. Though it cannot be seen directly, its presence can be detected through its effects, guiding charged particles and shaping the space around the planet. The magnetosphere extends thousands of kilometers into space, forming a protective boundary that interacts with the constant flow of particles emitted by the sun. This flow, known as the solar wind, travels outward in all directions, carrying energy and magnetic fields across the solar system. When it reaches Earth, it encounters the magnetosphere, which redirects most of these particles around the planet. On the side facing the sun, the magnetosphere is compressed, pushed inward by the pressure of the solar wind. On the opposite side, it stretches outward into a long tail that extends far into space. This shape is not fixed, but changes in response to variations in solar activity, expanding and contracting over time. Some charged particles from the solar wind are guided along the lines of Earth's magnetic field toward the polar regions. As they enter the upper atmosphere, they interact with gases, transferring energy and producing light. This process creates the auroras, faint and shifting displays that appear in high latitude skies. These lights move silently, forming patterns that ripple and change, reflecting the ongoing interaction between Earth and the sun. The sun itself is a steady source of energy, radiating light and heat across the vast distance to Earth. This energy arrives after traveling for several minutes through space, spreading across the planet's surface and atmosphere. While much of this energy warms the Earth, some is reflected back into space, maintaining a balance that keeps conditions relatively stable. At times, the sun releases bursts of energy in the form of solar flares or larger eruptions that send additional particles into space. When these reach Earth, they can temporarily alter the shape of the magnetosphere, increasing the intensity of auroras and affecting the flow of charged particles around the planet. Despite these variations, the magnetosphere continues to act as a shield, guiding and dispersing much of this energy. Earth's orbit around the Sun follows a path that is slightly elliptical, though it remains close to circular. This steady path ensures that the distance between Earth and the Sun changes only slightly over the course of a year. The consistency of this orbit contributes to the regular patterns of energy received by the planet. The gravitational influence of the Sun is the dominant force that keeps Earth in its orbit. At the same time, Earth exerts its own gravitational pull on nearby objects, most notably the Moon. This interaction creates a system in which both bodies move in relation to one another, maintaining a stable pattern that has continued over long periods. The Moon orbits Earth in a regular cycle, its position changing gradually from night to night. As it moves, the portion illuminated by the Sun shifts, creating phases that range from a thin crescent to a full circle. These changes occur in a predictable sequence, repeating approximately every 29.5 days. The presence of the Moon influences more than just its appearance in the sky. Its gravitational pull affects the oceans, contributing to the rise and fall of tides. This interaction between Earth and the Moon creates a subtle but continuous movement of water, linking the motion of the oceans to the rhythms of space. Beyond the Earth-Moon system, the planet is part of a larger structure known as the solar system. This system includes the Sun and a collection of other planets, each following its own orbit. Though separated by vast distances, these bodies are connected through gravity, forming a complex and balanced arrangement. Earth's position within this system places it between Venus and Mars, in a region where conditions allow for liquid water to exist at the surface. The balance of distance, energy, and atmospheric composition contributes to the environment observed on the planet. This balance is maintained through the steady interaction of forces that operate both within Earth and beyond it. The space surrounding Earth is not entirely empty. It contains small particles, fields, and radiation that move through the solar system. Satellites orbit within this region, following paths that keep them in continuous motion around the planet. These objects rely on the balance between gravity and forward motion, maintaining their position without falling to the surface. From a distance, Earth appears as a small luminous sphere, its surface patterns shifting as clouds move and continents rotate into view. The thin layer of atmosphere surrounding it creates a soft boundary, marking the transition between the planet and the darkness beyond. This view highlights the relative isolation of Earth, while also emphasizing its connection to the larger system in which it exists. Day and night are created by the rotation of Earth as it turns toward and away from the Sun. This rotation is steady and consistent, giving rise to the familiar cycle that repeats every 24 hours. As one side of the planet is illuminated, the other remains in shadow, and the boundary between them moves gradually across the surface. Twilight occurs during the transition between day and night, when the sun is just below the horizon. During this time, the atmosphere scatters light in a way that creates soft gradients of color, marking the shift from brightness to darkness, or from darkness to light. These transitions are brief, yet consistent, occurring each day as part of the planet's rotation. The interaction between Earth and space is ongoing, shaped by forces that extend far beyond the surface. Magnetic fields, gravitational influences, and streams of energy all contribute to a system that is both stable and dynamic. Though many of these processes are not directly visible, their effects can be observed in subtle ways, from the movement of auroras to the steady path of the moon across the sky. As we continue, we return once more to the surface, exploring the patterns of time, rotation, and cycles that define the experience of Earth, and the steady rhythms that unfold across days, months, and years. As Earth turns steadily through space, it creates the passage of time as it is experienced on the surface. This motion is constant and precise, forming cycles that repeat with quiet regularity. From the rotation that produces day and night to the orbit that defines the year, these patterns provide a structure that shapes both natural processes and human observation. The rotation of Earth occurs on an axis that runs from the North Pole to the South Pole. This axis remains tilted at an angle, and as the planet spins, different regions move into and out of the light of the sun. The result is the daily cycle of daylight and darkness, a rhythm that unfolds across the globe in a continuous wave. At any given moment, one half of the planet is illuminated, while the other remains in shadow. The boundary between these regions, known as the terminator, moves gradually across the surface as Earth rotates. This movement creates the transitions of sunrise and sunset, moments when light changes softly, marking the shift between day and night. The length of a day is measured by the time it takes for Earth to complete one full rotation relative to the Sun. This period is approximately 24 hours, though it is defined with precision using atomic clocks. Over long periods, small variations in rotation can occur, but these changes are minimal and do not disrupt the overall consistency of the cycle. Time is divided into zones across the planet to account for the rotation of Earth. As the sun appears to move across the sky, different regions experience midday at different moments. Time zones align human activity with this natural progression, creating a coordinated system that reflects the turning of the Earth. The tilt of Earth's axis plays a central role in the changing of seasons. As the planet orbits the sun, different parts of the surface receive varying amounts of sunlight. When one hemisphere is tilted toward the sun, it experiences longer days and more direct sunlight, while the opposite hemisphere receives less. This difference creates the gradual transitions between warmer and cooler periods. These seasonal changes occur in a predictable sequence. In one part of the orbit, the northern hemisphere is tilted toward the sun, bringing longer days and higher positions of the sun in the sky. Half a year later, the situation is reversed, and the southern hemisphere receives more direct sunlight. Between these points are periods of balance, when day and night are nearly equal in length across the planet. The path Earth follows around the sun is steady and repeated, completing one full orbit in about 365 days. This motion, combined with the axial tilt, creates the cycle of seasons that returns each year. Though the pattern is consistent, local conditions vary depending on geography, elevation, and proximity to large bodies of water. The concept of a year is based on this orbital period, marking the time it takes for Earth to return to the same position relative to the Sun. Calendars are designed to track this cycle, incorporating adjustments to account for slight differences between the orbital period and the standard measurement of days. Months are often associated with the cycle of the Moon, which orbits Earth in a period of about 29.5 days. The phases of the Moon provide a visible marker of this cycle, changing gradually from one night to the next. Though modern calendars are not strictly tied to lunar cycles, the connection remains evident in the structure of timekeeping. Natural cycles extend beyond the movement of Earth and the Moon. Many processes on the planet follow repeating patterns, from the flow of tides to the migration of water through the atmosphere and oceans. These cycles operate on different timescales, some occurring daily, others over months or years. The rise and fall of tides are among the most regular of these cycles. Influenced by the gravitational pull of the Moon and the Sun, tides create a steady movement of water along coastlines. In many regions, 2 high tides and 2 low tides occur each day, though the exact timing and height can vary depending on location. Daylight itself changes in duration throughout the year. Near the equator, the length of day and night remains relatively constant. In higher latitudes, the variation becomes more pronounced, with longer days in one part of the year and longer nights in another. In regions close to the poles, there are periods when the Sun remains above or below the horizon for extended times. The angle of sunlight also changes with the seasons. When the Sun is higher in the sky, its light is more direct, concentrating energy over a smaller area. When it is lower, the same amount of energy is spread over a larger surface, resulting in less intense heating. This difference contributes to the variation in temperatures observed throughout the year. Shadows shift in length and direction as the position of the Sun changes during the day. In the morning and evening, shadows are longer, stretching across the ground. At midday, when the Sun is higher, shadows become shorter. These subtle changes provide a visual indication of the passage of time. The steady motion of Earth creates a framework within which other processes unfold. Weather patterns, ocean currents, and the distribution of light and heat are all influenced by the rotation and orbit of the planet. These interactions form a network of cycles that operate together, each connected to the others. Time, as experienced on Earth, is both a measure and a rhythm. It marks the progression of events while also reflecting the underlying motions of the planet. The repetition of cycles provides a sense of continuity. As days follow nights and seasons return in their familiar sequence, the concept of time extends beyond human measurement, existing as a fundamental aspect of the planet's motion. Even without clocks or calendars, the cycles of Earth would continue, defined by the turning of the planet and its journey around the Sun. As we observe these patterns, there is a sense of calm in their regularity. The predictability of sunrise, the gradual change of seasons, and the steady flow of tides all reflect a system that operates with quiet precision. These cycles provide a stable background against which the details of the world unfold. And as we continue, we move into a closer view of the surface once more, exploring the diversity of environments that exist across the planet, from dry regions to areas shaped by water, each with its own patterns and characteristics. Across the surface of Earth, a wide range of environments can be found, each shaped by the interaction of land, water, and atmosphere. These environments vary in temperature, moisture, elevation, and composition, creating distinct regions that differ in appearance and character. Though each has its own qualities, all are connected through the broader systems that operate across the planet. Forests are among the most extensive of these environments, covering large areas of land with dense growth. In these regions, trees form layered canopies that filter sunlight, creating shaded spaces below. The air within forests often feels still, with sounds softened by the surrounding vegetation. Moisture is commonly retained within these areas, supporting a variety of plant life that grows at different heights. In some regions, forests remain warm throughout the year, receiving frequent rainfall. These areas are characterized by thick vegetation and a constant presence of moisture. In other regions, forests experience seasonal changes, with leaves altering in color and falling during cooler periods. These shifts create cycles that repeat annually, giving each forest a changing appearance over time. Grasslands extend across open areas, where trees are less common. In these regions, grasses dominate the landscape, forming wide expanses that move gently with the wind. The openness of grasslands allows sunlight to reach the ground more directly, creating conditions that differ from those found in forests. These areas often experience variations in rainfall that influence the height and density of vegetation. Deserts are defined by limited precipitation and wide temperature ranges. In these regions, the landscape is shaped by wind and occasional rainfall. Sand dunes form in areas where loose particles are carried and deposited, creating patterns that shift gradually over time. In rocky deserts, exposed surfaces display textures shaped by long periods of weathering. Despite the dryness, these regions can still support life adapted to the conditions. Mountain environments present a different set of characteristics. As elevation increases, temperatures generally decrease, and the air becomes thinner. The slopes of mountains may display different conditions at different heights, with distinct zones that reflect changes in temperature and moisture. Snow often accumulates at higher elevations, forming a contrast with the lower regions below. Wetlands form where land and water meet, creating areas that are partially or fully saturated for extended periods. These environments include marshes, swamps, and similar regions where water plays a central role. The presence of standing or slow-moving water creates conditions that differ from both dry land and open water, resulting in a unique combination of features. Coastal regions lie at the boundary between land and ocean. These areas are influenced by the movement of waves, tides, and currents. Sandy beaches, rocky shores, and estuaries each represent different forms of coastline, shaped by the interaction between water and land. The constant motion of the ocean contributes to the ongoing change of these environments. Freshwater environments include rivers, lakes, and streams that occur inland. These bodies of water vary in size, depth, and flow. Rivers move continuously, connecting higher elevations to lower ones, while lakes remain relatively still, reflecting the surrounding landscape. The presence of fresh water supports a range of conditions that differ from those found in the oceans. Polar regions are located near the northern and southern extremes of the planet. These areas experience lower temperatures and extended periods of daylight or darkness, depending on the time of year. Ice and snow are prominent features, covering large portions of the landscape. The surface in these regions can appear smooth and reflective, changing subtly with light and season. Each environment is shaped by a combination of factors, including the amount of sunlight received, the availability of water, and the structure of the land. These factors interact in complex ways, creating patterns that define the characteristics of each region. Though the differences between environments can be pronounced, they are part of a continuous system that connects the entire planet. Transitions between environments are often gradual rather than abrupt. A forest may give way to grassland, or a river may flow into a wetland before reaching the ocean. These transitions create areas where characteristics blend, forming zones that reflect elements of multiple environments. Such areas highlight the interconnected nature of Earth's surface. The distribution of environments across the planet is influenced by latitude, elevation, and proximity to oceans. Regions near the equator receive more direct sunlight, while those closer to the poles receive less. Elevation affects temperature and atmospheric pressure, while nearby water bodies can moderate local conditions. Together, these factors contribute to the arrangement of environments observed across the continents. Wind patterns also play a role in shaping environments by influencing the movement of moisture. Air that rises, cools, and releases precipitation can create regions with higher moisture levels, while descending air can lead to drier conditions. These patterns contribute to the formation of different types of environments in different parts of the world. The surface of Earth is constantly changing, though often at a pace that is difficult to observe directly. Over time, environments shift as landforms evolve and conditions vary. Rivers may alter their paths, coastlines may move, and vegetation may change in response to local factors. These gradual changes contribute to the ongoing development of the planet's surface. Despite these changes, there is a sense of balance within the diversity of environments. Each region operates within a set of conditions that remain relatively stable over time, allowing patterns to persist and repeat. This stability, combined with gradual change, creates a dynamic yet continuous system. From above, the diversity of Earth's environments forms a complex pattern of colors and textures. Green regions indicate dense vegetation, while lighter tones may represent dry or open areas. White areas near the poles reflect the presence of ice, while deep blue marks the extent of the oceans. Together, these features create the visual appearance of the planet as seen from space. As we continue, we move toward a broader perspective once more, bringing together the systems we have explored and reflecting on the quiet balance that allows Earth to function as a single, interconnected world. When viewed as a whole, Earth is not simply a collection of separate parts, but a single, interconnected system in which each component influences the others. The land, oceans, atmosphere, and interior are linked through continuous exchanges of energy and material, forming a balance that is both steady and dynamic. These connections operate quietly, often unnoticed, yet they shape the patterns that define the planet. Energy from the sun is one of the primary forces that drives this system. As sunlight reaches the Earth, it is absorbed by the surface and atmosphere, setting many processes into motion. Some of this energy warms the land and oceans, while some is reflected back into space. The balance between incoming and outgoing energy helps maintain the overall conditions of the planet. The distribution of this energy is uneven, with some regions receiving more direct sunlight than others. This difference creates movement within the atmosphere and oceans, as energy is transferred from areas of higher concentration to areas of lower concentration. Winds form as air moves to balance pressure differences, and ocean currents carry heat across great distances, linking distant regions through continuous motion. Water plays a central role in connecting Earth systems. It moves between the oceans, atmosphere, and land in a cycle that is both simple and complex. Evaporation lifts water into the air, condensation forms clouds, and precipitation returns water to the surface. Once on land, water may flow through rivers, seep into the ground, or return directly to the oceans, continuing the cycle. The movement of water also contributes to the shaping of the land. Rivers carve valleys, transport sediments, and create pathways that connect different regions. Over time, these processes alter the landscape, demonstrating the ongoing interaction between water and solid ground. The atmosphere interacts continuously with both land and ocean. Heat is exchanged at the surface. Moisture is transferred through evaporation and precipitation, and gases move between air and water. These interactions create patterns that influence weather and longer-term conditions, linking the behavior of the atmosphere to the features of the surface. Beneath the surface, the interior of the Earth contributes to this interconnected system through the movement of tectonic plates and the flow of heat from within. These processes shape the continents, form mountains, and create new crust. Though they occur slowly, their effects are visible in the structure of the land and the arrangement of oceans. The magnetic field extends this system beyond the surface, connecting Earth to the space environment. By guiding charged particles and interacting with the solar wind, it forms a boundary that influences how the planet interacts with the external forces. This connection highlights the way Earth is part of a larger system while maintaining its own internal balance. Time itself is woven into these connections. The rotation of Earth, the orbit around the Sun, and the cycles of the Moon all contribute to patterns that repeat with precision. These cycles provide a framework within which the interactions of land, water, and air unfold, creating rhythms that are both predictable and continuous. Each component of Earth's system responds to the others. Changes in one area can influence conditions elsewhere, sometimes over great distances. For example, the movement of warm ocean water can affect atmospheric patterns far away, while shifts in the atmosphere can alter conditions at the surface. These connections form a network of relationships that extend across the planet. Despite this complexity, the system maintains a sense of balance. Energy flows through it, materials are exchanged, and processes operate together in a way that sustains the overall structure. This balance is not static, but it is consistent, allowing patterns to persist even as details change. The scale of these interactions can be difficult to grasp. Some processes occur quickly, unfolding over hours or days, while others take place over years or much longer periods. Together, they form a continuous sequence of change and continuity, shaping the Earth in ways that are both subtle and profound. From a distance, the planet appears calm and unified, its features blending into a single image. Up close, however, it reveals a wide range of activity, with each part contributing to the whole. This contrast between simplicity and complexity is one of the defining characteristics of Earth. The connections between Earth systems extend beyond physical processes. They create patterns that can be observed and understood, offering insights into how the planet functions. By studying these patterns, it becomes possible to see the relationships that link different aspects of the world. As Earth continues its steady motion through space, these interactions remain in constant operation. The flow of energy, the movement of water, and the shifting of land all continue without interruption, forming a continuous cycle that defines the planet. There is a quiet consistency in this system, a sense that each part contributes to a larger whole. The oceans move, the atmosphere flows, and the land evolves, all within a framework that maintains balance over time. This continuity provides a foundation for the patterns that repeat across days, seasons, and years. In considering Earth as a connected system, it becomes clear that no single part exists in isolation. Each element is linked to others, forming a network that spans the entire planet. This network is both resilient and adaptable, capable of maintaining its structure while allowing for gradual change. As we approach the end of this journey, the details of Earth's systems come together into a single perspective. The planet is not defined by any one feature, but by the interaction of many, each contributing to the whole in a way that is both subtle and essential. And in this quiet balance, Earth continues to turn, its systems moving in harmony, creating a world that is at once stable, dynamic, and endlessly interconnected. As the view of Earth settles into stillness once more, the details of the planet begin to blend into a quiet, unified picture. The mountains, oceans, and atmosphere, each with their own motion and structure, become part of a single, continuous whole. From this perspective, the complexity of the world does not disappear, but softens into a steady presence, one that continues without interruption. The rotation of Earth carries the surface through cycles of light and darkness, a motion so consistent that it becomes almost unnoticeable. Day follows night, and night returns to day, forming a rhythm that continues without pause. This steady turning creates a sense of continuity, a reminder that the planet is always in motion, even when it feels still. Across the oceans, currents continue their slow paths, guided by differences in temperature and the rotation of the Earth. Waves rise and fall in repeating patterns, their motion shaped by wind and distance. Beneath the surface, deeper currents move quietly, connecting distant parts of the world through gradual circulation. On land, the shapes of continents remain in slow transition. Mountains rise and wear down, rivers carve their paths, and plains stretch across wide regions. These changes occur over long periods, often beyond immediate observation, yet they continue steadily, shaping the surface in subtle ways. The atmosphere flows above it all, moving in patterns that shift gently over time. Air rises and falls, clouds form and drift, and winds carry energy across the planet. These movements are part of a continuous exchange, linking the surface to the sky in an ongoing cycle. High above, the boundary between Earth and space remains soft and gradual. The magnetic field extends outward, guiding particles and shaping the invisible space around the planet. The sun provides a constant source of energy, its light traveling across space to reach the surface, where it is absorbed, reflected, and redistributed. The moon continues its orbit, marking time through its changing phases. Its presence influences the movement of the oceans, creating tides that rise and fall with regular precision. Together, Earth and the moon move through space in a steady pattern, guided by gravity and motion. Time, as it is experienced on Earth, emerges from these movements. The rotation defines the day, the orbit defines the year, and the cycles within the atmosphere and oceans create patterns that repeat. These rhythms provide a structure that remains consistent even as details shift and change. There is a sense of balance within these processes. Energy flows through the system, materials are exchanged, and motion continues at every scale. Some changes are immediate and visible, while others unfold slowly, shaping the planet over long spans of time. Together, they form a system that is both dynamic and stable. The surface of Earth reflects this balance. Water moves through oceans and rivers, air circulates through the atmosphere, and the land evolves under the influence of internal and external forces. Each part contributes to the whole, creating a network of connections that extends across the planet. From a distance, Earth appears calm, its colors blending into a soft pattern of blue, green, and white. Clouds drift across the surface, partially obscuring the land and sea below. The edges of the atmosphere glow faintly against the darkness of space, marking the boundary of the world. As the planet turns, different regions come into view, each with its own characteristics. Yet from afar, these differences merge into a single image, one that reflects the unity of the system as a whole. This perspective reveals both the diversity and the coherence of Earth. The motion of the planet continues without interruption. It spins on its axis, travels along its orbit, and moves within the broader structure of the solar system. These movements are steady and predictable, forming patterns that repeat across time. Within this steady motion, there is a quiet sense of continuity. The cycles of day and night, the progression of seasons, and the flow of water and air all contribute to a rhythm that persists. This rhythm provides a foundation upon which the details of the world unfold. As the narration comes to a close, the focus remains on this sense of calm continuity. Earth is a planet defined not only by its features, but by the relationships between them. The interactions of land, water, air, and energy create a system that operates with quiet precision. The details we have explored, from the depths of the interior to the heights of the atmosphere, come together as parts of a single whole. Each process, each movement, contributes to the balance that defines the planet. Though complex, this balance remains steady, allowing the world to continue in its constant motion. There is no sudden ending to these processes. The Earth does not pause or conclude, but continues as it always has, turning through space, its systems in motion. The oceans will keep moving, the atmosphere will continue to flow, and the land will slowly change over time. In this ongoing movement, there is a sense of quiet persistence. The planet remains, its patterns repeating, its systems interacting, its motion unbroken. This continuity extends beyond any single moment, forming a sequence that continues indefinitely. And so, the view of Earth settles into stillness once more, not because the planet has stopped, but because its motion is so steady, so consistent, that it becomes a background presence, a world in motion, yet calm, a system in balance, yet always changing, a planet that continues, quietly and endlessly, through the vastness of space.